Hello there, today we'll be doing balanced binary trees. In this particular problem, we will be checking out a tree like this. And it is balanced as long as the left and right item or node is within 1 of each other. Otherwise, the height difference is greater than 1, then it is no longer balanced, so return false. So return true or false in this particular problem. In this particular case here, it is false because the height difference is, I think, was 1 here and 3 here. So the total height difference between these two is a total of 2, and so this is an incorrect answer. However, if we did not have this layer here, and the total height difference is between a 2 and a 1, which is going to be within 1. And so how do we get this height difference? Well, we have to return the total height between the left and the right and get the max height between the two and return it to our top node so that we can realize when it is when the height difference is greater than 1. So let's make that the case. We're going to do a top-down DFS. So this means that we have to go all the way down, so left, right. So we'll be running a pre-order traversal. So we need to go all the way down first to 4. And once we hit the base case, we're going to return a 0 if the height difference, and that's the total height that we're going to return. So we're returning 0 at this particular point, and at this particular point we return the height of 1 because we will add 1 to the height, the max of the height of left and right, which is 0, and so there's a total height of 1. The same here with 4. And I don't think I need to do any more zeros because that's just going to, I think maybe we'll just write it out anyways for descriptiveness. So height difference between these two is a 0 because 1 minus 1 is 0. And we offer this max height between the two and we add 1. So now we have 2 here. At this particular point, 0, 0, we'll have a total of 1 height difference. And of course this 2 has 0, 0. Because there are no numbers. So with that, the total height difference at this particular point is 1, 2 minus 1, the absolute value. So because we don't know which is left and which is we know which is left and which is right, but we don't know which one's bigger or smaller. So then we still have a height difference of 1. So we're still going to keep going. And return the bigger of the two, plus 1, which is a total of 3 here, and we're going to have a total of 1 here. 3 minus 1 is going to be a total of 2. 2 is greater than our item, so let's just break out of that, because we know for sure it's going to be false. Alright, with that, we will be done with this particular problem. So, remember, what we're going to do is a DFS call. So, define DFS. We need a root, and we're going to return a number, which is going to be our the maximum height at that particular point. So first thing we need is a maximum height difference. So we need a max height difference equals 0 at this point. We're going to take that and make it a non-local. With this, we need to make a base case. So if not roots and max height difference is less than or greater than 1, that means that means we can return 0 and we're done here, and that means we can finish off all the excess calculations that we need to, that we're still doing, or even so let's just keep going. So we're going to run DFS for root.left and DFS for root.right. And now we can calculate the max height difference because this is going to return the left height and this is going to return the right height. Especially when we know for sure that we're returning the max of the left height and the max of the right height plus 1. Before we we return this answer, we need to get our max height difference, which is equal to the max of the max height difference, and the left and the absolute value of the left height minus the right height. And with that, we are done here, and we're good to go. Let's run this DFS function and return whether the max height difference is greater than or equal to, well, less than or equal to 1. There's no root. None type has no attribute left. That is weird because we made sure. Oh, it's the or. Perfect. This answer was pretty good according to this problem set. It was much faster according to a different problem set, but this is how we answer the isBalance function. We did a top-down approach, and once we got to the bottom of our tree, we were able to return the max height at that particular point between the two, left and right height. And we were able to calculate the max height difference and end early with a base case check where max height difference is greater than 1. And that's all for this particular problem. So, if you enjoyed this video, like and subscribe. Want more videos, check the link in the description below. If you have any questions at all, please comment below, and I'll see you in the next one. Bye!